Hey guys, welcome back. At this point, we are able to successfully write and execute MapReduce programs, pig Latin instructions, and Hive QL queries in our Hadoop cluster. That is great. Every time we executed a MapReduce job or a pig or a Hive script, it resulted in a successful execution. But in real world, we can certainly hope for success all the time, but that is not going to be the reality. You will experience some failures along the way, and when it happens, you should be prepared to troubleshoot failures. We see many Hadoop courses teach this awesome framework but never talk about failures and how to troubleshoot them. It's a shame because when a critical job fails, that's when your day gets stressful at work, especially when your boss and the business users are expecting an ETA to fix the issue and see the result. That is the primary reason we wanted to talk about handling failures and troubleshooting. Troubleshooting a failed job is one great skill to learn, but we can do a few things to minimize the failures in the first place. So in this lesson, we'll see how to test our MapReduce programs using MRUnit. Whenever someone asks me to review a MapReduce job before it can be deployed into prod, the very first thing I look for is unit test cases. I'll look for test scripts that were written using tools like MRUnit, understand the test cases, execute them myself, and review the results. Let's say you just finished writing a MapReduce job. You feel very comfortable and confident about the programs you wrote. But how can you know for certain at runtime your mapper and reducer will work exactly as you thought it would? The only way to find out is to actually test your code. JUnit is an excellent tool of choice to unit test your programs. JUnit has been around for many years, allowing developers to unit test their Java programs functionality by functionality before any code can be promoted to production or any environments for that matter. For those of you who are not familiar with JUnit, it helps you to test individual functionalities in your program in isolation to others. It is very simple. It could even be a very small function. You supply the input, and as a developer, you know what the output should be, and you test the output of the JUnit execution with the intended output. MRUnit is a library that helps you write JUnit test scripts for MapReduce programs. You can test your mappers and reducers in isolation using MRUnit. You can supply an input and the expected output for your mapper or reducer and execute the JUnit test to test the actual output with the expected output. If both your actual and expected output match, your test is a success. If not, it's a failure. Super simple, right? Let's see what we need to execute a JUnit test. Let's take a look at our maximum closing price MapReduce project. You need the MRUnit library in your class path. We are using Maven to manage the dependencies for the project. So let's open the pom.xml file to go over the dependencies. Here in the pom.xml, you will see MRUnit version 1.1 for Hadoop version 2 or MapReduce version 2. Once this dependency is added to the pom.xml, check your Maven dependencies. You will now see MRUnit and JUnit libraries added to the list of dependencies. Perfect. We are all set in our project to write MRUnit test scripts. Let's take a look at the max close price test program under test. In this program, we have two test methods, one to test the mapper and the other one to test the reducer. If you can recollect, the maximum closing price MapReduce job computes the maximum closing price per symbol. In the mapper, for each stock record will emit the symbol as the key and closing price for that record as the value. The reduce will receive all the closing prices for a stock, and the reducer will calculate the maximum closing price from the list of closing prices for the stock symbol. The very first thing you will do in your program is to define the specification for your mapper, reducer, and MapReduce program as a whole. The mapper will receive long writable, which is the record offset in the file, and text, which is the actual stock record itself, as input, and will output text for symbol and float writable for closing price for each record. And hence you will define the types for the mapper as highlighted. The reducer will get the map output as input. So text for symbol and collection of float writables for closing prices. The reducer will output symbol and maximum closing prices for the output, so text and float writable. So we specify the appropriate types for the reducer as well. We should also define the MapReduce job or the driver. The types for our mapper input is listed as the first two types. The third and the fourth type represent both mapper output and reducer input. The fifth and the sixth type represent reducer output. Now we have defined mapper, reducer, and the driver program. Let's look at the other methods now. Each method in this program is annotated. The setup method is called before any methods are called because it's annotated with add before. In this method, you will instantiate the mapper, reducer, and driver programs. You will use them in testing the mapper and reducer programs. As you can see, the test mapper method is annotated as addTest, which means this method is a JUnit test. The method is very simple to follow. Take a look at the first two lines. You're using the map driver you created in the setup method and you're saying test this input for this output. You have to specify both the input records and the expected output using the with input and with output method. If you look at the record, ORR is the symbol and 13.15 is the closing price. So this mapper, when it executes for this record, should return ORR and 13.15 as the output. If it did, the mapper is functioning as expected. If it did not, the mapper has issues. Similarly, we test for another record. Finally, we call run test on the map driver to execute the test. We do something very similar to test the reducer. Again, we will define the input and the expected output. Here, ORB is the symbol and we are providing two closing prices for the value, 15.80 and 13.2. The reducer should compute the maximum closing price of the two, which is 15.80. And this is our expected output. So we set the with input and the with output methods accordingly and run the test by calling run test on the reduce driver. Now our MRUnit program is ready to run and we can execute the program as a JUnit program. So go to run, click on run as JUnit test. Let's go ahead and execute this. There you go. Both test cases are successful. When the expected output does not match the actual output from the code, you will see an error. Let's try to change the expected output of the reducer to 13.2. Now when you run the test case, it will fail. Let's go ahead and try it. There you go. As you can see, our test reducer failed because the expected output 13.2 is not what we got. We got actually 15.8 from the reducer. Since the expected output and the actual output did not match, this JUnit test case failed. So there is something wrong with either the reduce or our test case itself. So now we have unit tested our program. Now we can run this in our cluster, right? Sorry, not yet. We have unit tested our program, but we have not tested the job as a whole yet. Before you run anything new on the cluster, you should always test the job with a smaller subset of data and examine the job's output. This will give you the confidence that the job will work well in your cluster with your full-blown dataset. Even with all this, a job can still fail due to any number of reasons. It could be bad data, it could be due to not enough memory, etc. But at least we have done our due diligence to make sure the job has the best chance to be successful in an ideal environment. So to summarize, in this lesson, we saw how to write MRUnit test programs to unit test our MapReduce code. As a best practice, always write MRUnit test scripts to test your mapper and reducer first, and once satisfied with the test results, execute the job with a smaller dataset before you deploy the job in the cluster against a bigger dataset. With that, let's wrap this lesson. See you in the next lesson.